Hello everyone. Today I will introduce the topic of software quality assurance and testing. This is a critical aspect of software development as it directly impacts reliability, performance, and user experience. In the time ahead, I will guide you through the core concepts, methodologies, and practical applications of SQA and testing in real-world projects. I hope today's presentation will provide you with valuable insights. Let's start with the basics. What is Software Quality Assurance, or SQA? SQA is a process that verifies whether software meets specified requirements. It ensures that the software is free from defects, reliable, and aligns with user expectations. Why is SQA so important? First, it reduces the cost associated with fixing defects after the software has been released. Second, it boosts user satisfaction and trust. And third, it improves the overall reliability and the performance of the software. In essence, SQA is key to the success of any software product. What are the core objectives of SQA? First and foremost, SQA aims to prevent defects by implementing proactive processes. For instance, identifying issues during the requirements analysis phase can save a lot of trouble down the line. Second, it ensures that software adheres to industry standards like ISO or IEEE. Third, it focuses on enhancing the reliability and the performance of the software, making sure it runs smoothly across various environments. Fourth, it aims to increase user satisfaction and trust, which is crucial for user retention. Lastly, by addressing issues early, SQA helps reduce long-term maintenance costs, minimizing the need for frequent fixes and upgrades. These objectives form the foundation of SQA practices. SQA is integrated throughout the Software Development Lifecycle, or SDLC. During the requirement analysis phase, it ensures that requirements are clear and testable. In the design phase, it involves reviewing design documents to spot potential problems. During implementation, code reviews and unit testing are conducted. The testing phase is where functional and non-functional tests are executed. Once the software is deployed, performance is monitored and user feedback is collected. Finally, during maintenance, defects are addressed and the quality is continuously improved. SQA isn't just a single phase, but a continuous process that spans the entire SDLC. Now, let's delve into the different types of testing. We have functional testing, which includes unit testing, integration testing, system testing, and acceptance testing. Then there's non-functional testing, covering aspects like performance, security, usability, and compatibility. Testing can also be categorized by levels: unit testing, integration testing, system testing, and acceptance testing. Additionally, testing methods include white box testing, which is from the developer's perspective, black box testing, which is from the user's perspective, and gray box testing, which combines both. These categories help us comprehensively cover various aspects of the software. Functional testing. Unit testing. Test individual code units, e.g., functions or methods, to ensure they work as expected. Integration testing. Test the interaction between multiple modules to ensure they work together correctly. System testing. Test the entire software in a complete system environment to verify it meets the requirements. Acceptance testing, conducted by users or stakeholders to confirm if the software meets business requirements. Non-functional testing, performance testing, checks the software's response time and resource usage under high load. Security testing ensures the software is protected against vulnerabilities and threats, safeguarding sensitive data. Usability testing evaluates whether the software is easy to use and if users can complete tasks effortlessly. Compatibility testing verifies the software runs correctly across different devices, browsers, and operating systems. Testing levels, unit testing, written by developers to test individual code units. Integration testing, test the interfaces and interactions between modules. System testing tests the entire system in a full environment. Acceptance testing validates by users or stakeholders if the software meets requirements. Testing methods, white box testing, tests the internal code structure and is typically done by developers. Black box testing tests external functionality and is usually conducted by testers or users. Gray box testing combines white box and black box testing with partial knowledge of internal structure but a focus on external behavior. Let's compare white box testing and black box testing. White box testing focuses on the internal code structure and is typically conducted by developers. Examples include unit testing and code coverage testing. On the other hand, black box testing is concerned with external functionality and is usually performed by testers or end users. Examples here are functional testing and usability testing. Using both approaches together allows for a more comprehensive defect detection process. Now, let's look at some common testing types. Performance testing ensures that the software can handle the expected load and performs efficiently. Security testing is crucial for protecting the software against threats and vulnerabilities. Usability testing focuses on ensuring that the software is user-friendly, and compatibility testing verifies that the software functions correctly across different devices, operating systems, and environments. These testing types help evaluate the software from various angles, ensuring a high-quality product. Testing in network environments presents unique challenges. First, there is the issue of latency and bandwidth, which requires testing under real-world network conditions to ensure the software performs well. Then there's cross-platform compatibility, ensuring the software works seamlessly across various devices and operating systems. Scalability is another concern, testing how the software handles increased loads as user numbers grow. Lastly, security testing is vital to protect against the network-based attacks. These challenges necessitate a more comprehensive testing strategy tailored for networked software. Automation tools play a significant role in modern software testing. Selenium is widely used for testing web applications. Geometer is a popular choice for performance testing. Appium is designed for mobile application testing. JUnit is a neat testing framework for Java, and TestNG is a more comprehensive testing framework. These tools enhance testing efficiency, especially in regression testing and frequent builds. allowing for faster and more reliable test execution. Test-driven development, or TDD, is a popular development approach. The core idea is to write tests before writing the actual code. What are the benefits of TDD? It reduces defects by catching issues early, improves code quality through continuous refinement, and encourages better design by thinking through the requirements before implementation. The TDD process is straightforward. Write a test, run it, and expect it to fail. Write the code to make the test pass. Refactor the code for efficiency and readability, and then repeat the cycle. This approach ensures that the code is reliable from the ground up. Agile testing is an integral part of Agile software development. Its principles include continuous and iterative testing, close collaboration between developers and the testers, and a strong focus on customer satisfaction. However, Agile testing comes with its own set of challenges. Requirements can change rapidly, which means tests need to be adaptable. There is also the need for quick feedback loops to keep the development process moving smoothly. These challenges require flexible testing strategies that can evolve with the project. DevOps and continuous testing are significant trends of modern software development. Continuous testing involves integrating automated tests into CI/CD pipelines, ensuring that the software is rigorously tested at every stage of development. The benefits are substantial. Faster feedback allows issues to be addressed promptly. Risks are reduced through early detection, and the release frequency is improved, enabling faster time to market. Tools like Jenkins, GitLab CI, and CircleCI are instrumental in achieving efficient and effective continuous testing. Now, let's look at a real-world case study involving a banking application. The testing focus for this project included security testing to safeguard sensitive customer data, performance testing to ensure the system could handle high volumes of transactions, and compatibility testing to ensure seamless operation across various devices and browsers. The outcome was impressive. A 40% reduction in defects and a notable improvement in user satisfaction. This case study highlights the tangible benefits of robust SQA and testing practices in real projects. What does the future hold for SQA and testing? Several trends are emerging. AI and machine learning are being leveraged for predictive analytics to detect defects early in the development process. Shift-left testing emphasizes moving testing to earlier stages of the development cycle, catching issues before they become costly to fix. IoT testing is becoming increasingly important as more devices become interconnected, ensuring compatibility across a wide range of IoT devices. Lastly, cloud-based testing offers scalable and cost-effective environments, allowing teams to test under various conditions without heavy infrastructure investments. These trends promise to make testing more efficient and effective in the coming years. To wrap up, let's discuss some best practices for SQA and testing. First, start early by integrating testing into the development lifecycle from the beginning. Second, automate repetitive tasks where possible to save time and reduce human error. Third, foster collaboration among developers, testers, and stakeholders to ensure everyone is aligned. Fourth, document everything thoroughly, including test plans, cases, and the results for future reference and improvement. Lastly, prioritize defects by addressing the most critical issues first to ensure the software's stability and reliability. Implementing these practices can lead to a more efficient and effective testing process. In conclusion, SQA and testing are indispensable for the success of any software product. Striking the right balance between manual and automated testing is essential, as each has its unique advantages. Continuous improvement and staying adaptable to new trends will ensure that testing practices remain effective and relevant. I'll end with a quote from Aristotle. "Quality is not an act, it is a habit. Let's strive to make quality a habit in everything we do." Thank you for your attention, and I hope today's presentation has been insightful. Thank you for listening.